Hello. Oh my, you see some work there. Let me get rid of that. Ignore that, please. Okay, so we're going to cover fractions. Today, some of the stuff we talked about in class, we'll do some equivalent fractions. We'll do some looking for common denominators and also look for the greatest common factor. So it's going to be a busy video. Pause and rewind if you have to, but I'll try to get as much of it in as I can. Okay, so the first thing we'll do is we'll look at a fraction and we'll do some equivalent fractions. So 1/2. There we go. So if I was looking at a model of 1/2, I would have two pieces. There you go. That'd be a model of 1/2, and then one of those pieces would be colored in. That's 1/2. Now let's say that I wanted to make an equivalent fraction, so I wanted to make the same fraction, but I wanted to make it into fourths. Right? So how can I make 1/2 equivalent to 2/4? Over here I'll put 2/4. How can I make those two fractions equivalent? Well, I'll jump ahead and tell you right now that they are equivalent. 1/2 does equal 2/4. How did I get from 2 to 4, and how did I get from 1 to 2? How did my numerator and denominator change? Well, if I have 2/4 and I color in 2 out of the 4 pieces, right? 4 is the denominator, 4 pieces. 2 is the denominator, 2 pieces. The numerator shows how many are shaded in or how many we're using. 1 here, 2 here. It's the same size. You can tell that if I drew a line here, there, it's the same size for 1/2 and 2/4 because they're equal. So how did I get there? Well, I used multiplication, right? 2 times 2 is 4. Whatever I do to the bottom, I have to do as well to the top. So 1 times 2 is 2, 2 times 2 is 4. So I just made an equivalent fraction. I made it bigger. I made an equivalent fraction that had 2 pieces, 1/2, and I turned it into an equivalent fraction that has 4 pieces, 2/4. Now, it can actually move both ways. So let's take a number, let's do 6/12. Okay, I can multiply the top and bottom by 2, and that'll give me a new fraction. 6 times 2 is 12. 12 times 2 is 24. Those are equivalent. 6/12 is equivalent to 12/24. All right, if I was to model this out, it would be the same size because our parts got bigger and the pieces we're using got bigger. They doubled, essentially. So I can make equivalent fractions by multiplying. I can also make equivalent fractions by dividing, by going smaller, which is what we're going to need here in a little bit. So I want to take this fraction and make it smaller. So instead of multiplying, I'm going to divide. And dividing should make both numbers smaller. I have to find, just like I did up here, I multiplied times 2, and I got 12/24. I need to divide by the same number. But division is tricky because certain numbers aren't divisible by certain other numbers. All right, so how do I figure out what two numbers to divide by? Well, we use a thing called U-turns here. We've got about 100 of them, almost 100. No, I think we're at 70 we've completed so far. So let me show you what a U-turn looks like. We take the two numbers, 6 and 12. Okay, and 6/12, so that's our fraction. So numerator and our denominator. So I'm going to do U-turns for both of these, and we'll find what we call the greatest common factor. Right? The biggest number that they have in common that we can divide by. So we need all the factors, right? We need the factors of 6, numbers that multiply to make 6. We always start out with 1, because it's the one number that multiplies by everything. And then we check our 2's. Is anything 2 times 3 equals 6? Okay. We don't reverse them. We don't have to do the reciprocal. So 2 times 3, it stays like that. We don't have to write 3 times 2 because it's the same thing, right? So 1 times 6, 2 times 3. There's no 4's. That 4 times nothing equals 6. There's no 5's. We have 6 already there. So that's it. Those are all of them. We can't go any higher than 6. And that U-turn is done. So now we look at the 12. Again, we start with 1. We look at our 2's. We know that 2 times 6 is 12. We know there's a 3 because 3 times 4 is 12. And this is why your multiplication facts are so important. You have to know these in and out because it helps tremendously when doing this. We know there's no, we got 3 times 4, no 5, we have a 6, 7 times nothing equals 12, no 8, no 9, so we're done. That's it. So I've done my 2 U-turns. Now I'm looking for the greatest common factor. The factor, the number that each of them have, that's the biggest that they have in common. And you can tell by looking at it, I'm sure, that that number is, there's a 6 here and a 6 here. That's the greatest one. Now, yeah, they both have 2's in common, and they both have 3's in common. But I'm looking for the greatest common factor, the biggest number that they both divide by. So now I can take my original fraction of 6/12, and I can divide both of those by 6, because I've already established they both have 6 as a factor. So 6 divided by 6 is 1, 12 divided by 6 is 2. I've just reduced my fraction, which is the second part of the lesson, reducing fractions. So I made an equivalent fraction, but I also reduced it. I did 2 things. So I multiplied to make an equivalent fraction, and I divided to make an equivalent fraction. And using this skill by division, because division makes numbers smaller, I've actually reduced my fraction or made my fraction into simplest terms. You might see that as well. So let's do a couple more just so you can get an idea, and I'll give you one to practice. So let's do 8/16. Now I can make an equivalent fraction, sure, but what I really want to do is reduce this fraction into its simplest form. Instead of 16 parts, I want something easier to work with. So I would do my U-turns for 8 and 16, right? We know it's 1 times 8, we know it's 2 times 4, and that's all we have for 8. For 16, we know that's 1 times 16, we know that's 2 times 8, there's no 3, there is a 4 times 4, and those are all of our factors. So look for the greatest common factor again. It's going to be, there's an 8 here, that's the biggest one, 8 here. Now yeah, there's a 2 and there's a 4, but the greatest, the biggest is 8. So we can divide both of these by 8. 8 divided by 8 is 1, 16 divided by 8 is 2. So again, I have reduced my fraction into its simplest form, 1/2. So those are kind of the skills we're working with. Finding a least common denominator, we'll do that one real quick. It's a little more complicated, but let's say I have 2 fractions, 1/3 and let's do 2/5. And I want to make fractions based on these 2 that have the same denominator. Right? I want to have common denominators. And we're going to need that for stuff like adding and subtracting fractions. We're going to need to find common denominators. So how do I find a denominator to change these fractions into 2 fractions with the same denominator? Well, that's when we do something we call LCM, least common multiple. So this focuses on the denominators, 3 and 5. So underneath here we'll make a 3 and 5. And this is the general rule of thumb that I like to tell my students is we're going to skip count at least 5 times. And then if we have to go more, we'll go more. But let's do at least 5 times. So we have 3, 6, 9, 12, 15. Right? That's 5 times. And let's do 5. 5, 10, 15, 20, 25. So now I'm looking for, instead of the greatest, I'm not looking for greatest anymore, I'm looking for least. The least common multiple. So the number that they have in common that is the smallest. There's no 3, there's no 5, 6, no 9, no, there's no 12 here, there's no 10 there. So the number they have in common that is the smallest is 15. So I do this weird, funky circle both of them thing. Right? So now I have 15 is a number that they both have in common. That's their least common multiple. Okay, so I'll rewrite my fraction over here so we can have a little room to work. So I have 1/3 and I have 2/5. And I've established right over here that 15 is a denominator that they both have in common. So how do I get to there? How do I get to 15? How did I get from 3 to 15? Well, I multiplied. I know that because the number got bigger. And just a little hint, if you ever kind of, you know, you have a brain fart or you forgot how to multiply, you can come back and look. How many times did you skip count? 1, 2, 3, 4, 5. Excuse me, that means I multiplied 5 times. 3 times 5 is 15. 1 times 5 is 5. So here's my new fraction that has 15 as a denominator. So that means this fraction over here, I need to do the same thing. 5 times what? 5 times 3 is 15. So I need to do the same to the top. 2 times 3 is 6. So now I have 2 fractions. I have 5/15ths and 6/15ths. So why do I need to have fractions with common denominators? What's the whole point of that? Well, there's a couple of different reasons. One is we're going to compare them. Let's say we're going to do less than, equal to, or greater than, right? Let's say we're going to do that and figure out, compare them, 5/16ths to 6/15ths. Well, coming over here, if I was going to compare them, I might have to draw this out, you know, and use some brain power to figure this out. But now that I have the same denominator, I can tell that 5 is less than 6. So 5/15ths is definitely less than 6/15ths. Super easy, right? Another thing we might need this for is to, and this will come later, but let's add fractions. 5/15ths plus 6/15ths. Right? So we would just, denominators don't add. They stay the same. And we just add the 5 plus 6. So you just learned how to add fractions, and you didn't even know you were going to do that today. I'll give you one as a challenge to compare the fractions, find the common denominator, add them together, and reduce them. So let's see if you can do that. If you can't, don't worry about it. We'll be in class tomorrow. So let me give you the challenge problem. Let's do 3/6, and we're going to compare. Oh, you know what? Let's compare it to 2/12. Make it easier. So we have 3/6 and 2/12. I want you to find the denominator. Find the common denominator. Should be pretty easy. So make both fractions that have the same denominator. Then try to add them together. And then once you add them together, see if you can reduce the fraction to its simplest form. Now again, this is only a challenge. You don't have to do this. Hopefully this will help you with your homework. Good luck, and we'll see you tomorrow. If you have any questions, comments, put them below. I'll try to answer them. Have a good night.